Okay, good morning. We're going to restart our presentation session. We're going to have our second presenter, which is Dirli Aprilia, which is going to talk about identification of subsurface structure using graffiti method in the Mujakarta area. Okay, Dirli, could you set up your presentation?
Okay, sir.
Okay, before Dearly start her presentation, I would like to remind the audience for today's session to fill in the assessment sheet for each presenters, and also I would like to remind the speakers or the presenter of today's session to use the pointer that is embedded in the PowerPoint. Okay, Dearly, the time is yours.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning and hello everyone. Okay, my name is Dirli Aprilia, and today I will present a final of my research related to the identification of subsurface using graffiti method in the Mujakarta area. Okay. Indonesia is a large country full of natural resources and rich for oil and gas. Oil and gas field can be found spread within the country. One of them is Java Basin, located in the Mujakarta area. As reported on the Geological Survey Institute of Indonesia, provided by on the Ministry of Energy and Mineral Resources website, this basin, especially the one located at the northern part, is one of the main hydrocarbon producers in Indonesia. Given the large amount of energy potential in the East Java Basin, special care must be taken in managing and utilizing it to optimize the use of resources in the East Java Basin, particularly in supporting resource sector activities. Accurate data integrity and information sector monitoring is required. So how do we occur it? We can identify what it's contained in the subsurface to prove whether it is true that there are oil and gas source in the Mujakarta area by using the graffiti method. It is an effective method widely used to analyze the structure of the underground surface, which is present in the form of graffiti anomaly data. And the benefit of this research is to find out the outspread and the depth of basins around the Mujakarta area. Next, yeah. The modern graffiti measuring device is now known as a graffiti meter. The basic principle of this graffiti meter is similar to a spring with a constant mass. As you can see on figure 2, the basic principle of the Lacoste and Rombe graffiti meter represent a simplified illustration of the graffiti meter principle. When measuring the gravity of a certain location, a change in the value of gravity named G will cause change in the mass named M of the gravity meter. This phenomenon will cause this spring with the initial length named S to be stretched and become longer due to change in gravity. Hooke's law, as you can see on equation 1 and 2, states that the change in spring length is proportional to the force that causes it. You're usually called the spring force, where M is a content mass in gravity meter, and K is the elastic spring constant. Next is regional stratigraphy in East Java Basin, as you can see on figure 3. According to subsurface data from hydrocarbon exploration in this area, the Pachiran Formation can be it's the oldest exposed stratigraphic unit, primarily composed of claystone with limestone and sandstone inserts, especially at the bottom. The last one is Pachiran Formation, the youngest stratigraphic unit in the system. This formation is composed of massive limestone from the surface. This formation can be indicated from the deteriorated constituent rocks that turn into chalky limestone. This formation is mostly found in the northern part of the Rembang zone and was formed around the Pliocene to the early Pleistocene era. Next, this overall research work can be seen from this flow chart. This research was begun with a literature review so that the author can thoroughly understand the basic of the gravity method and how it is used in geothermal identification. This important information will support the author during this research. However, because there are limitations in taking data directly to the field during the COVID-19 pandemic, this research will be conducted using the existing data. Thereafter, the data is processed to obtain the result, which is interpreted through forward modeling, and this study will also be supported by geology information data and other data, if any such log data, seismic data, etc., so on, so that the subsurface structure can be interpreted properly. Okay. Next is data acquisition method. In data acquisition using the gravity method, a measurement instrument in the form of a Lacoste and Rombi gravimeter is used. Gravimeters measure the value of the gravitational field due to subsurface mass anomaly. Research data taken in the field are gravimeter readings, data collection time, coordinates, and height of measuring station, as well as topography around the measuring station. In data collection, it is necessary to be careful in using the gravimeter so that the gravimeter doesn't experience shocks during measurement or during mobilization, because it will affect the accuracy of the streaming reading. Okay. Next is data processing. After the data acquisition stage, the next stage is data processing, which is used to make subsurface geological structure modeling. This data processing consists of several stages, including conversion of gravity value into milligal, followed by data reduction, which consists of drift correction, free air correction, tidal correction, Bugge correction, latitude correction, and terrain correction. Then the Bugge anomaly data is filtered to separate regional and residual anomalies by filtering moving average, which will then is used to carry out the forward modeling. The gravity anomaly data obtained should be separated to residual anomalies. And in this study, qualitative interpretation was carried out by reading the gravitational anomaly pattern, which was the link to the geological setting and other geological data with gravity forward modeling. Forward modeling is a form of modeling in which a model that represents subsurface anomalies is solved. This modeling used the concept of trial and error, determining the parameter values to produce a model that fits the field data values. And the result, the research begins with digitizing the Bugge gravity anomaly map. Following that is data processing, which begins with the projection of the Bugge gravity anomaly data onto a plane. After correcting the gravity data, the results of the complete Bugge anomaly value are obtained. As you can see on figure 6, complete Bugge anomaly map, the obtained data originate from the East Java Basin with values ranging from minus 180 milligal to 140 milligal. To the low anomaly, it's represented by the blue color, as you can see on the figure, which is mostly concentrated in the northwest part of the basin, whereas the high anomaly is represented by the pink color, which is predominant located in the southern part. A high anomaly indicates a rock structure with a higher density in comparison to the surrounding area, while a low anomaly indicates a rock structure with a lower density. Next, furthermore, the residual anomaly separation step that is useful for this next stage, namely forward modeling, requires slicing to predict the depth of the basin surface. A two-dimensional model is created by slicing 11 paths across the residual gravity field anomaly contour from line A to line K. As in this figure, the modeling assumes that the subsurface structure consists of 3 layers. The topmost layer is a tertiary sedimentary layer with a density of 2.1 gram per cube of centimeters at blue color for the northern part. Meanwhile, the layer below it is pre-tertiary rock with an average density of 2.2 gram per cube of centimeter. Finally, the basement layer consists of granitic and basaltic layer with a density of 2.47 gram per cube centimeters. According to the contour map shown in this slide, East Java has a tertiary sedimentary basin with a depth of more than 6,000 meters, with the basin axis located in the center of the island, which is believed to be a large hydrocarbon producer. At the blue color, dark blue. Based on geological data from Geological Survey Institute of Indonesia, in the northern northern zone, rocks are fault and cut by an active north-south fault. The general trend of the faulting axis is west-east. The sedimentary form in sequence of sandstone, alternating with mudstone. The northern zone is also characterized by thick sediment of mud and marl. For the reason, the sedimentation process in this zone has been going on in Oligocene condition. So the conclusion, there are two conclusions, and one in the modeling, it is assumed that subsurface structure consists of 3 layers. The top layer is the layer tertiary sediments, continued to the pre-tertiary layer, and the third is the granitic and basaltic layers. And so modeling shows that East Java has a depth of tertiary sedimentary basin that is up to 6 kilometers. The center of the basin is located in the middle of East Java, especially at Mujakarta area. It is suspected that there are hydrocarbon traps. However, for more in-depth investigation and analysis, geology, geophysics, and geodesy studies are required. Thank you for your attention. If you have any question, please ask me now. Thank you.
Okay, thank you, Dirli. Questions from the audience for Dirli? Okay, we have Nabila at the moment. Okay, Nabila, please ask the question.
Okay, sir, thank you. So Dirli, is there a relationship between the anomaly values and the depth of the basin you described earlier? What is the correlation between them two?
Okay, wait. Okay, well, thank you for your question, Nabila. Yes, there is a direct relationship. The greater the value of the anomaly can be, the deeper the depth of the basin will be, and vice versa. By seeing the depth of the basin, we can find out the existence of a basin that can produce hydrocarbons. As you can see in dark blue, the depth is 6 kilometers. That anomaly, that the anomaly is very big than the others. Yeah, I think it's enough.
Okay, is that answering your question?
Yes, sir. Okay. Thank you, Dirli.
Okay, so the next question is going from Jovan.
Okay, Dirli, are there any other models available besides forward modeling? And can we interpret it in 3 dimensions?
Okay. Yes, there are basically 2 models that are usually used for data interpretation, namely gravity forward modeling and inversion modeling. Forward modeling is modeling to describe the data from a model by calculating the theoretical response and the distribution of properties of the anomaly source. Meanwhile, inversion modeling is a modeling that is used to describe the modeling of the measurement data in the field by analyzing the theoretical study of the model obtained. Actually, the interpretation in a 3-dimension will be better than 2-dimensional, more accurate in the real world. But it takes a long time to complete it, and the technique is so difficult. So I use 2 dimensions now. Okay, thank you.
Thank you.
Okay, the last question for Dearly will be coming up from Hauda.
I want to ask, can you interpret this data by going through the steps of separating the anomaly residual from the CBA map?
Okay. Unfortunately, you cannot, as the Pga anomaly map, complete Pga anomaly map provides a comprehensive picture of the mass causing the anomaly consists of a combination of various variation in mass density that are distributed both vertically and horizontally. In general, gravity anomaly is caused by 2 things, namely regional anomaly and residual anomaly. Regional anomalies, on the other hand, provide a broader description of geological condition in this area characterized by low frequency anomalies. Therefore, in order to interpret the data, we need residual anomaly to for the next stage to forward modeling. Is that answering?
Yes, thank you, Darwin.
Okay, you're welcome.
Okay, there is a quick question from me. Could you move to the forward modeling scheme? Okay, I just want to confirm whether the distance in the horizontal axis, is it in meters or in kilometers?
In meters, sir.
Oh, okay, so 5,000 meters is 5 kilometers. 5 kilometers is a short distance. It's just like from my house to ITB, right? But
Right.
your line A, okay, this is coming out from line A, right? Okay, go back to your line A. Line A is stretching from the north of what is that? Cepu area to the south of Blitar area, right? So, it is not actual Blitar area, but it is long. I mean, is it a 5 kilometer? Is it a 5 kilometer cross section? I don't think so. So I just want to confirm whether this the unit that you show is correct.
Okay, sir. I want to explain again. So line A, I think you can see it's more than 5 kilometers, 6 kilometers, yeah. But I use for modeling. It's not full line A. Just I cut at the anomaly, a big anomaly. At pink color. So
okay.
So
If that's the case, then you need to describe in details, okay? Because it's going to mislead the audience, because you have line A, okay, in the previous figure that is stretching from north to the south of the western part of East Java, which is thousands in kilometer, but now you show the forward modeling computation in just for 5 kilometers. Okay, so that's verified my question. Okay, thank you, Dearly, for your talk. So that we can move on to our third presenter, which is Ayunda Putri Melina, talking about consumer behavior analysis on e-commerce of Shopee.
Yes, sir.
Okay, whenever you're ready.
Okay. So, hello, good morning, everyone. I'm Marinda Putri
Morning.
Nalina, and the title of my presentation is Consumer Behavior Analysis on e-commerce Shopee using agent-based modeling method. So, the first one, I want to tell you the background of this research. As you know, that the global population is currently facing one of the most life-threatening disasters since the last century, generally referred to as COVID-19. And several national governments have implemented lockdown restrictions to reduce the risk of infection. And also in Indonesia, we have many regulations to reduce the risk of this pandemic, such as PSBB and PPKM. And the coronavirus impact is on all aspects of life, and one of them is on how people fulfill their needs. The coronavirus pandemic has pushed many people to make their purchases online, as many physical retail outlets across the world are either closed due to lockdown measures or have limited capacities to maintain social distancing. And the thing that interesting from this phenomenon is the behavior of customer who use and make online purchasing process through Shopee. I choose Shopee because on 2020, from my brush, Shopee is nominated to the most visited platform in Indonesia. And this is the purpose of my research. The first one is to develop customer behavior model for an optimal marketing strategy by modeling customer behavior. The second one is to offer a better service for customer. And the last one is to help increase product sales. And then the method that I choose to observe this phenomenon is agent-based modeling. Agent-based modeling is a bottom-up approach to understanding systems, which provides a powerful tool for analyzing complex non-linear market. And the method involves creating artificial agents designed to mimic the attributes and behavior of their real-world counterparts. And the simulation output may be potentially used for explanatory, exploratory, and predictive purpose. And in this model, customer will consider as agent, and agent is interact with environment. And then this is an agent-based simulation model for Shopee potential customer. And following the characteristic of ABM, potential Shopee customer have various characteristics during the simulation. And in this study, use three characteristics of agents, and the first one is disseminator. Immediately spread innovations, which is the consumers, and in this case, consumers are people who are purchase product on Shopee. And then the second one is explorer. Explorer primarily prioritize the end of trying innovation before deciding whether to deploy or not. And in this case, explorer is people who are still confused between buying the product or not. And the last one is do nothing. Do nothing is a group of people who respond to receive message about innovation and do nothing about it. In this case, do nothing people are people who have never accessed Shopee. And also from this figure, it shows explorer is divided into two. There is satisfied and unsatisfied. And if the customer is satisfied, they will divide it into two again. And the first one is disseminator further. Disseminator further is customer that buy a product, and no further action if the customer do not buy the product. And then these are the parameters that will be used in this study. This parameter is distributed and filled out by 7 regarding customer satisfaction. Using this is a question that is question with yes or no answer, and question with answer using a scale of 1 to 10. And from the questionnaire, we can determine the parameter that will be used in the study. The first one is accessibility. Accessibility is the level of satisfaction regarding the ease of accessing Shopee. And then promo is the level of satisfaction regarding the promo provided by Shopee. And then price is the level of satisfaction regarding the price of products. And service is the level of satisfaction regarding Shopee customer service. And the last one is effectiveness, is the level of satisfaction regarding the ease of finding the product, what are we looking for on Shopee. And so the input of this research is variation of parameters value that affect Shopee customer buying decision. And with agent-based modeling, we can get the simulation model of Shopee customer. And now we have an agent-based model. So the agent of this study are potential customers. And the attribute of agent is characteristic agent, which is disseminator, explorer, and do nothing. And the customer satisfaction parameter in Shopee, which is accessibility, promo, price, service, effectiveness. And then the behavior of agent is customer decision on buying product on Shopee. And then this is the flow chart that will be used in the program. Start, and then over some product, of course, online. And then I use agent is less than 770. And then if the customer is not buy a product, they will the program will do the iteration, or the program will be finished. But if the customer is buy a product, and if they satisfied, the program can do the iteration again, or just finish. But if the customer is unsatisfied, the program will directly finish. And this is the NetLogo interface and generated from the previous flowchart. The program that I use is a modification of the Twitter program inspired by some of the basic models in NetLogo model library. And in the simulation, 770 agents were used to determine customer behavior on a number of potential customer. And the decimeter used in the simulation is obtained from a summary of the result of the questionnaire, and which is as much as 80%. And explorer were obtained from respondents who conduct further search as much as 20%, with the same value as probe try. And while the network density, it shows the population in the system, and this is there are only one sales platform offering to access Shopee. And this is in addition, the variation are made on the parameter used by shifting the NetLogo, which functions to determine the effect of parameters on product at Shopee. And then by changing this value, it will produce a visualization. And here is the chart of jumlah prediksi konsumen Shopee. And from this chart, we will know the predicted number of Shopee consumers who buy product at Shopee, or Shopee consumer who only access Shopee. And then here with the environment, if show its green color will indicate agent who buy product at Shopee, and if red color indicates Shopee consumer who only access the Shopee application. And in this study, the model will be validated by using extreme validation. And from this figure shows that if all parameters are in maximum value, will make all potential Shopee customer will interest to buy a Shopee to buy a product on Shopee. And also from here shows all agents color are green, and which is they show the same thing. So this from model validation show that this model can be used for simulating the consumer behavior of potential Shopee customer on decision to buy a product or not. And then so the result, the first one is the result of IBM simulation on Shopee potential customer on male. And for male, use accessibility is 8, promo 8, service 7, effectiveness 8, and price 8. And then from this simulation, show that there are 658 people who are interested to buy a product at Shopee from 770 Shopee's potential consumer, and the time it takes it 13% of the total time of tasting of potential customer to receive information on the platform and decide to buy or not to buy the product. And in addition, shows that 28% of the total explorer finally decided to buy the product after searching more deeply about the related parameter. And this is the result of IBM simulation on Shopee's potential customer on female. For female customer, the parameter used where accessibility is 9, promo is 8, service is 8, effectiveness is 9, and price is 9. And from the simulation, we can know that there are 694 people who are interested and buy product at Shopee from 770 Shopee's potential customer, and the time required is 12% of the total time of testing all potential all time. And then from the simulation also show that 51% of the total explorer finally decide to buy the product after searching more deeply about the related parameters. And this is the result of IBM simulation on Shopee potential customer on all gender, and the parameter that used is accessibility is 8, promo is 8, service is 8, effectiveness is 9, and price is 8. And from the simulation, we can know that there are 680 people who are interested and buy product at Shopee from 770 Shopee's potential customer, and the time takes is 14% of the total time of testing all potential customers to receive information on the platform and decide to buy or not to buy the product. And in addition, the simulation also shows that 42% of the total explorer finally decide to buy the product after searching more deeply about the related parameters. And so the conclusion of my research is the first one. IBM method can be used for analyze consumer behavior of Shopee's potential customer, and the parameters, which is accessibility, promo, price, service, and effectiveness, have an impact on Shopee's product purchase decision. And for Shopee Insight is Shopee needs to improve the quality of accessibility, effectiveness, and service on our platform, and also improve suitable price of product and give promo that makes more explorer decide to buy this product. And I think that is all from me. If you have any question, you can ask me now.
Okay, question from Ayunda. Is there any question? Okay, we have Rifki, Aleta, and okay, so there are two participants. Okay, Rifki.
Hello, can you hear me?
Yes.
So first of all, thank you so much, Ayunda, for your presentation. That's really great. As a Shopee user myself, I'm a little bit curious about this project. On the result, I think it's on slide 11 or 12. You mentioned that the percentage of explorer become the disseminator or the buyer. So my question is, how do we get the number of the explorer become the disseminator from the simulation? Thank you.
So as we know that the first one, we know that the percentage of disseminator is 80% of the total agent or jumlah konsumen. And if we multiply the disseminator percentage of disseminator with jumlah konsumen, we can know the number of disseminators. And from this chart, exactly here, when this line starts constantly, it shows that the simulation is done. And in this point, especially in this green line, we can get the number of agents that decide to buy a product and Shopee, and we can know the number of explorer become disseminator by subtracting this number with the number of disseminators. I think like that.
Oh, so the number of that buy on the chart is subtracting by the disseminator of 80%. I think like that, right?
Yeah.
Oh,
Sure.
okay. Thank you so much. Thank you so much, Ayunda.
Okay, the next question will be coming from Aleta.
Okay, thank you for the opportunity for asking. Ayunda, I just curious, is there any difference result between male and female agent?
Okay. So there is no significant difference between the result of male and female agent, but from this data, we can know that the number of female agents who decide to buy a product at Shopee is higher, which is 694, and for male is 658. And also the number of this is show the number of explorer who become disseminator for female agents is higher than male. I think like that.
Okay. Thank you so much, Ayunda, for the answer.
Thank you, Aleta.
Is there any more question from the audience? Okay, Yunda, could you verify the horizontal axis on the simulation graph? Could you move back to the what? Okay, let's use this one. The time that you have in the horizontal axis, is it in seconds or what?
In seconds.
In seconds. So people will have approximately 10 seconds to decide whether they are going to buy or to browse or something, or this is a computational time.
This is a computational time.
Okay, so that's the computational time for the simulation.
Yeah.
Oh, okay, so yeah, I think for your so is this part of your final project?
No, it's my incremental, sir.
Oh, okay. Okay. So it's basically your independent study. Yeah. I mean, I think it is better to describe the time there in a little bit more details on what time is that. Probably on the report of the independent studies, you mentioned about it, but in this presentation, probably I'm kind of missed during the talk, but it is supposedly talking about the computational time. Okay, thank you, Ayunda.
Yeah, thank you, sir.
Okay, let us wait for another 2 minutes before we are moving on to our fourth presenter. Okay, for those of you who wants to go to the toilet or to have some kind of a quick refreshment before we moving on to the four presenters, the time is given about 2 minutes for a small break. Okay, let us continue our presentation session to the fourth presenter, which is going to be Hans Timothy Christian Simanjorang.
Okay, sir. It's okay.
Yeah, we can see your screen. Maybe you could make it full. Okay, whenever you're ready.
Okay. Okay, good morning all. Let
Okay,
me
good morning.
introduce myself. My name is Hans Timothy Christian Simanjorang. I am from Physics of Earth and Complex System Research Division, Institute Teknologi Bandung. Today, I want to present about Papandayan volcano subsurface structure using Magneto method. Okay, the background. The result of population growth is in the need for energy. Sources of energy from fossils are getting thinner day by day, so it is necessary to make effort to find renewable energy. One of the renewable energy potential that is widespread in Indonesia is geothermal energy. Based on news electronic media, that there is 40% reserve geothermal energy is in Indonesia from total reserves world, and Indonesia is a country that has the largest geothermal reserves in the world because Indonesia is in the ring of fire zone. Generally, geothermal prospect areas are in volcanic areas. Mount Papandayan is a stratovolcano located in Garut Regency, West Java. Some of the surface geothermal appearances as hot pools, hot mud, and hot springs are found at the foot of the hills, as seen in Papandayan and its surrounding. Geothermal search in several areas in Indonesia has done. Various methods has been applied to determine the location of geothermal energy in the area. The method currently being growing in Indonesia for search geothermal energy location is a method Magneto Theoretic. The purpose of this research is to help searching for geothermal energy location using the Magneto Theoretic method. The Magneto Theoretic method. The MT method is a sounding method that passively measures that the wave natural electromagnetic or EM. Magneto-telluric method has a penetration range which is deeper than the electromagnetic. The MT method can knowing the distribution of rocks and layers in the below of the surface by looking at the value of resistivity of type resistances. The parameters to be analyzed from the measurement results with this method are apparent resistivity and phase parameters. Based on subsurface resistivity mapping data, further estimates will be made regarding the composition of geothermal system, namely the geothermal reservoir, the location of the clay cleft, and the location of other components of the geothermal system below the surface. The natural electromagnetic waves propagate in a vertical direction on the Earth because the differentiation in resistivity between air and Earth is quite large. The EM field is generated by various processes, quite complex physics with a very wide frequency spectrum in order -5 to order 4. Okay. The Maxwell equation. Maxwell equation, which describes the behavior of the EM field, is synthesis of the laws that apply to the electromagnetic phenomena. Uses the equation, the MT method has been widely described in introductory geophysics books, especially those discussing the EM method. There are 4 laws in Maxwell equation. The first is Faraday's law of induction. The second is Ampere-Maxwell law. The third is Gauss electric law. And the fourth is Gauss magnetic law. We can see the form of the integral form and the differential form, where the E is for electric field, and B for flux or magnetic induction, and H for magnetic field, and J for current density, D for electric transfer, and rho for electric charge density. Next, the skin depth. The incoming electromagnetic waves at surface will decay from the initial amplitude, which is called by the term skin depth. The skin depth is the distance along electric field strength attenuated by a strong initial electric field. Skin depth can be written with the following equation, with rho is resistivity and F for frequency. Magneto Theoretic acquisition. Data recording time is usually done up to a dozen hours so that the measurement data enough to describe the condition below the surface to a depth of thousands of meters. The MTU tool will record the time variation of the magnetic field and electric field, which will store in a removable flashcard. The sensor used for recording the data consists of 2 types sensor, namely sensor electric and magnetic sensors. Electrical sensor function to record electric field data, and the magnetic sensor serves to record magnetic field data. There are 3 sensor magnetic field consisting of 3 coils, HX, HY, and HZ. There is the pictures of MT2 recording data in the form of parameter EX, EY, HX, HY, and HZ with respect to the time. Next, the magnetotelluric data processing. The data that has been recorded on the MTU device in the form of raw data for electric and magnetic field magnet with respect to time. Selection on measurement time interval affect data quality. The longer the time interval, the more data can be obtained. After that, the data in the time domain will be converted into the frequency domain with Fourier transformation. After that Fourier transformation, the impedance value will be calculated, apparent and phase resistivity using robust processing. Robust processing is used to reduce noise and create data better. Then the empty data processing followed by mapping and inversion of the data measurement. This is the picture of the result of data processing with the noise to the data has been reduced. frequency to apparent resistivity, and the frequency to the phase. One-dimensional data at one measurement point will be inverted and combined with other measurement point data put into one track. The inversion processing result data in the form of two-dimensional image of resistivity values to the depth. The picture is an example of a two-dimensional image where at the depth of less than 1,000 meters, there is a distribution of cover layers. The covering layers of rock cover is formed due to the hydrothermal process, which is a process that occurs due to reaction between the original rocks and geothermal fluids. The deeper the resistivity value rises again and gets higher as the depth increases in the measurement of the path. Based on the arrangement of layers in geothermal system, that under the rock cover there is a reservoir area at the depth of approximately 2,000 to 3,000 meters. The conclusion is Papandayan volcano is a source of geothermal for geothermal energy reserves. The second is the magnetotelluric method can be used to find geothermal energy sources. And the last is geothermal reservoirs area are usually under the cover layer of about 2,000 meters. Okay, thank you. If you have any question, you can tell me now.
Okay, thank you, Hans. Question for Hans from the audience? Okay, we have Nabila. And okay, we start from Nabila, please.
Okay, sir, thank you. So Hans, thank you for your presentation. I want to ask about the frequency. So in your method, where does the frequency comes from? And so what is the source of the frequency, and how much is the frequency that you use?
The empty method, the frequency source can be from inside or outside the earth. It from within the earth, it usually caused by the movement between the earth's mantle and the earth's core. Meanwhile, from outside the earth, it usually caused by lightning strike and solar wind. Usually, the frequency produced by the lightning is above 1 Hz and the solar wind below 1 Hz.
Okay, is that answering your question? I guess the question is that do Han know what is the frequency range of his of the measurement that was talking about here?
Yes,
is that the question? Okay. Okay, Hans, do you know what is the frequency range of this study?
Yes, sir.
Yeah. Could you explain about it?
The range of the frequency about the Magneto
in Papandayan. Okay, in Papandayan. I'm not talking about the source of the high and low frequency here. What Nabila is asking is that do you know what is the frequency range of the Papandayan measurement that you're talking about here?
Oh, for the Papandayan.
Yes, I think that's
I
the
don't
question.
know, sir. I don't know.
Oh, you do not.
Yes.
Okay. Is that is it mentioned?
For
do you remember
general,
whether it's mentioned in the paper or not?
What's that?
Do you remember? Are you remember if whether the frequency range is mentioned in the paper or not?
Not, sir.
Oh, okay. Okay, I guess that's the answer for Nabila. Okay, thank you, Nabila.
Thank you, Hans. Thank you, sir.
Okay. The second question is coming from Nermina.
Yeah. Thank you, sir, for the change. Hans, I have a question. Where do you get the formula for the skin depth? Can you explain? And what do we get from the formula? Thank you.
The skin depth. Okay. This formula, how I can tell how to get the formula because it's very long, but I can explain it now. Sorry, but what we get from the skin depth is the smaller frequency, the greater the skin depth can we get, and the greater of resistivity and the greater the skin depth and its reverse.
Okay, is that answering your question, Nermina?
Yeah. Thank you, Hans.
Okay. With that, we would like to thank Nabila and Nermina and also Hans for the interaction. We're going to move on to Rifka Rahayu talking about the PGA on Sulawesi Island. Okay, so let's thanks. Okay, is Rifka Rahayu in the audience? Okay. Okay, whenever you're ready.
Okay. Assalamualaikum warahmatullahi wabarakatuh.
Salam warahmatullahi.
Good morning, everyone. Let me introduce myself. My name is Rifka Rahayu from Institut Teknologi Bandung. In this opportunity, I would like to present the Vigrant acceleration analysis of 2000 until 2020 earthquake data using the STEPA method in West Sulawesi. Okay, first, I will explain to you about the objectives of this research. That is to determine the Vigrant acceleration value in West Sulawesi based on earthquake data from 2000 until 2020 using the STEPA method. Why this is important? Because by knowing the PGA value, we can estimate how much the damage caused by an earthquake so that disaster mitigation can be done. Okay. The first one is this is the introduction about earthquake in Indonesia, where earthquake is the shaking of the earth due to the sudden movement of rock layers on the earth crust due to the movement of the tectonic plates. In this picture, we can see that there have been many earthquakes that have occurred from the beginning of 2021 until October 2021. The question is, why is Indonesia quite prone to earthquake? Okay, this is because Indonesia is located on the Asia-Pacific volcanic route, which is a path prone to seismic activity. And then Indonesia is also traversed by three world tectonic plates that continue to move relative to one another, namely the Indo-Australian, Asian, and Pacific plates. Okay, next, earthquake in West Sulawesi. We know that West Sulawesi is one of the island it's one of the province in Indonesia, which is located on the island of Sulawesi. And also, West Sulawesi is a province that is quite prone to earthquake. Why? Why is West Sulawesi is quite prone to earthquake? This is because the existence of a fault in the earth crust on the island of Sulawesi with quite large dimensions, namely the Palu Koro Fault. And then, according to Indonesian Agency for Meteorology, Climatology, and Geophysics, or BMKG data, West Sulawesi have occurred at least 7 destructive earthquakes that caused a lot of damage and human casualties. And this picture shows the damage caused by an earthquake in Mamuju, January 2021. Okay, well, one of parameters that can determine the size of the damage caused by an earthquake is Vigrant acceleration. Vigrant acceleration is an indicator of the ground acceleration that occurs in a place due to an earthquake and can be determined by using an accelerometer and also by empirical approaches such as the Esteva, Donovan, Mygur, Richter, and so on. And this picture shows the accelerometer located at BMKG Goa, South Sulawesi. Okay, in this study, the Pga value will be analyzed and will be determined using the Esteva method based on earthquake data in West Sulawesi from 2000 until 2020, where the formula can be seen in the equation 1, where A is a Pga value in gal or centimeter per second quadrat, M is earthquake magnitude, and R is the hypocenter distance in kilometer. And also, the formula of the hypocenter and epicenter can be seen in the equation 2, where delta is the epicenter distance in kilometer, h is the depth of the earthquake source in kilometer, and lat and lon is stand for latitude and longitude. And also in this picture, in this figure 4, we can see the relationship between epicenter, hypocenter, and the observation point. Okay, the next section is about methodology. First, research time and location, where the data of this research is taken from 2000 until 2020, and the location is in province of West Sulawesi. And then the tools and materials that we use are earthquake catalog of 2000 until 2020, and in West Sulawesi with the magnitude bigger and equal to 4, and the depth is smaller and equal to 60 kilometers. And we also used Microsoft Excel and ArcGIS to do the data processing. Okay, next is research procedure. The first thing to do is preparing an earthquake data, where the data can be downloaded from USGS, United States Geological Survey website. The second one, determine the measurement points are grid, where in the study there are 41 measurement points were used. Third, determine the epicenter and hypocenter distance using the equation 2 on the previous slide. Next, calculating the Pga value in each grid using the Esteva method, where the calculation is done by using Microsoft Excel. And then determine the largest Pga value on each grid, creating a Pga contour map using interpolation method in ArcGIS. And the last one is analyzing the value using Pga to MMI scale conversion table to determine the risk level of damage caused by an earthquake. Okay, this section is the result of this research. First is this picture is the map of the measurement points, where there are 41 measurement points distributed in this research area and marked with a blue triangle as seen in this slide. And the distance of each point or grid is 35 kilometers. Okay, after determining the measurement point, the largest Pga value is determined on each grid so that the Pga contour map is obtained. And this is the picture of the contour map of Vigrant acceleration or Pga in West Sulawesi using the Esteva method, where the Pga values are classified into 5 classes, which are marked with dark green, light green, yellow, orange, and red colors as seen in the map on this slide. And then based on this contour map, it can be seen that the areas that have the largest Pga value are areas around the Mamasa Regency and some areas in Mamuju Regency. which have a Pigrant acceleration values from 48.25 until 61.97 gal or centimeter per second quadrat. And then areas around Majene, Polewali Mandar, Mamuju, and Central Mamuju Regency have Pga values that vary from 18.85 until 48.25 gal. And then the area around North Mamuju or Pasangkayu Regency has a fairly small Pigrant acceleration value, which range from 6.44 until 29.10 gal. Okay, now the question is why in each area has a different Pga value. Okay, the answer is the difference in the Pga value in each area are caused by the value of the earthquake magnitude, the distance from the epicenter and hypocenter to the observation point, the depth of the earthquake source, and the geological conditions of each area. Where the greater the magnitude of the earthquake, the greater the Pga value, the closer the distance from the epicenter and hypocenter to the observation point, the greater the Pga value, the deeper of the depth of the earthquake source, the smaller the Pga value, and the different geological condition in each area also cause the Pga value in each area to vary. And then after getting the Pga value in each area, we will also determine the risk level of the damage caused by an earthquake in West Sulawesi, where the Pga value will be connected with the intensity of earthquake using the scale of modified Mercalli intensity or MMI scale conversion, which can be seen in the table 1. Based on this table, it can be seen that Mamasa Regency and some areas in Mamuju Regency that have the largest Pga value is included in level 5 to 6 MMI with the potential damage is very like to like. And then areas around the district of Majene, Polewali Mandar, Mamuju, and Central Mamuju have a Pga value that is included in level 4 to 6 MMI with the potential damage is known, very light, and light. And the last in the area around the North Mamuju or Pasangkayu Regency as a smallest Pga value is included in level 2 until 5 MMI where the potential damage is known and very light. Okay, next is here are some effects will occur in an area based on the Pga value that has been converted to the MMI scale, where in the province of West Sulawesi, the scale value is around 2 until 6 MMI. And this is some of the perceived effects are like dishes rattle, walls crack, window rattle, and then in 5 MMI felt by nearly all brightens a view, and then trees and bushes shaken noticeably. And for the 6 MMI, many objects fall from shelf, a few intents of violent plaster, broken windows, and damaged chimneys within the community. Some fall of tree, limbs, and tops, isolated rock falls and landslide, and isolated liquefaction. Okay, and so on, like we can see in this table. For 2 MMI, 3, 4, 5, and 6 MMI. Okay. Finally, there are 3 conclusions based on this research. The first one is Pga value in West Sulawesi province is around 6.44 until 61.97 gal, where the largest Pga value is around Mamasa Regency, and the smallest Pga value is in the area around the Pasangkayu Regency. The second, The difference in Pga values in each area are caused by the value of the earthquake magnitude, the distance from the epicenter and hypocenter to the observation point, the depth of the earthquake source, and geological conditions of each area. And then the last is the risk level of the damage caused by an earthquake in West Sulawesi is obtained, where the highest level is 6 mmi, with the potential damage is like, and the smallest is 2 mmi, with the potential damage is none. This is my presentation. Thank you very much for your attention. Good morning. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, questions for Rika? Okay, we have Anggita. Do we have another question from the audience? Okay, let's start from Anggita.
Okay, thank you for the time. So for Rika, I have two questions here for your research. First, why did you choose to use the STFA method, and why not another method? And the second one is, why should an empirical approach be used? Even though we know there is an accelerometer that can directly determine the Pga value due to an earthquake. Thank you.
Okay, thank you for the question. The first one is the answer of the question one. Why I choose the STFA method? Why not the other method? Okay, there are several reasons why I choose the STFA method. The first is we know that the calculation of STFA method is only requires magnitude and hypocenter distance, where this data is quite easy to obtain from the data processing of seismograph. And then when I did, the second reason is when I did my internship at BMKG, I also did research which was related to the empirical method that can estimate the value of Pga based on the accelerometer recording from the earthquake in Mamasa, West Sulawesi, where it was found that among several empirical methods, that is the STFA, Donovan, and Mygur, the method that gives the result closest to the result of the accelerometer is the STFA method. So in this research, I also choose the STFA method. And my last reasons is that there has been no research that I know that determine the value of Pga in West Sulawesi by using the STFA method. So that by choosing this method is expected to make a new contribution in this field of this research. I think that's for the question one, and the question two is why should an empirical approach is used? Why not just use the accelerometer? This is because accelerometer, we know accelerometer are not evenly distributed throughout Indonesia. Just some areas that have an accelerometer. So due to these limitations, an empirical approaches is needed to calculate the Pga value in an area that not have the accelerometer. I think that's thank you.
Okay.
Thank you.
Do we have more questions for Rifka? Okay. If it's not, then we're going to continue to our last presenter of today's session. Okay. Thank you, Rifka. Which is going to be Arfian, and the topic that he select for the presentation is industrial application of digital rock image technology.
Excuse me, sir.
Yes.
I'm sorry. I just prepared the presentation from the today, but accidentally in the middle of my friend's presentation, my laptop is freezing until now.
Oh, okay.
I'm so sorry. I just figured it out to restart it, but it keeps freezing and lagging. So
okay. Could you restart your computer? Okay. Because we have 30 minutes until 9 o'clock, so no need to worry about it.
Okay. Okay, let me try it again.
Yeah, okay. So while we waiting for Afian to prepare his presentation, I would like to remind the students here to upload their final presentation file into the given Google Drive link that is provided in the EduNext LMS. And also, if you done with your final paper, okay, the link for the folder is also provided in the EduNext.
Excuse me, sir. Hello.
Yes.
Okay. I think it's apa? I think it's done. I can wait. Share the screen. Okay.
Okay, whenever you're ready, you may start your presentation.
Wait a minute. Is my voice clear and my screen
Yes.
can be seen? Okay. Assalamualaikum warahmatullahi wabarakatuh. Good day, everyone. My name is Arpian Sindika Pramasta from Physics of Earth and Complex System Research Division, Bachelor of Physics Study Program Institut Teknologi Bandung. So today I would like to present you about my research about industrial application of digital rock image technology. Okay, so the outline of this presentation, the first one is we talk about the background and then subsurface reservoir, type of core analysis, imaging, image analysis, method, results, and summary or conclusion. Okay, background. So for the background, the aim of the digital rock image technology is thus to derive a digital transcription of a reservoir rock and then perform numerical simulations of transport process on this obtained digital structure. The purpose of this research is to provide an overview of the current state of digital rock image technology with emphasis on industrial application. So let's talk about subsurface reservoir characteristics. So there are two types of subsurface reservoir characteristics. The first one is data obtained from surface, and the second one is data obtained from wells. The difference between these two types of subsurface is the first one is have low resolution and large coverage, and then data obtained from wells have high resolution and low coverage. In data obtained from surface, we can collect the seismic data, electromagnetic data, and gravimetric data. And then in data obtained from wells, we can collect well logs data, transient pressure testing data, reservoir performance data, and core and drill cutting. But in this research, we focus on well logs data. Okay, type of core analysis. So there are two types of core analysis. The first one is conventional core analysis or CCA, and the second one is special core analysis or SCAL. Conventional core analysis including porosity, permeability, and grain density, and then special core analysis including capillary pressure, relative permeability, and electrical properties. So, imaging. In digital rock physics workflows, imaging of rock samples typically has a twofold purpose. The first one is to obtain sample description, and the second one is to obtain 3D structures for computation of effective properties. Calculation of effective rock properties from digitized image of the pore structure requires an image resolution that sufficiently resolves all parts of the structure, important for the property in question. In imaging, we have 3D imaging and 2D imaging. Now, the first one is 3D imaging, three-dimensional imaging. So, in 3D, there are one method we use is X-ray computed tomography or CT. Reconstruct a 3D image of sample from a set of X-ray image of the sample taken at different angles. We can see in figure 1 that is just the example of CT tomography. Okay, and then we come to two-dimensional imaging. So in 2D imaging, there are several microscopy methods which produce high-resolution image of rock samples. The most common is backscattered electron atau BSA image from scanning electron microscopes of SEM. BSA is routinely applied to acquire image with resolution in the sub-micron scale, and such BSA images are commonly used in rock characterization. So we move on to image analysis. So basically after we collect the data from imaging section, we analyze that image in this section. So this is the part of image analysis. The first one is porosity classification. So porosity information is obtained from image by segmentation. When excluding fractures, sandstone porosity can be classified into three types: intergranular, dissolution, and micro. The intergranular porosity is the primary porosity between the grains. The separation between effective and micro porosity is thus dependent on the image resolution and image quality. After we analyze porosity, then we analyze grain size distribution. The grain size distribution is an integral part of the sedimentological description of reservoir rock. Grain size can be extracted directly from a segmented image whenever the image resolves the individual grains. Codes for extracting the grain size are readily available in visualization software such as Imagy and Avizo. So we can see in figure 3, grain size analysis on a binary image consisting of matrix and porosity. The figure on the left shows the distance to the nearest porosity voxel. The center image shows maximal balls inside the matrix, and the right figure shows the results applying a weighted Waters algorithm starting in the ball centers. So we move on to method. So in this method, we have some assumption or boundaries. So the first one is samples with resolved porosity mass larger than 10%, and then clay content between 15%. Radius ratio between smallest and larger grain should not be much larger than 1 to 10. This workflow builds on assumption of homogeneity. We assume the existence of rock types with similar cross property trends. So this is the big picture of the workflows. So the first one, we do some rock characterization from imaging, and then we create a digital rock model from that. And then after we have the digital rock model, we process that model and we create some flow parameters. So this is the detail of workflow. So it starts from both the satellite and the main field. After that, visual inspection of core viewing indicated similar geological features in wells from the satellite and the main field. After that, we're doing the log interpretation. Based on log interpretation, we conclude that the wells contain 3 different rock types, visually classified as fine, medium, and coarse sand. All 3 rock types consist of homogeneous sand. After that, a set of thin sections were chosen to cover the internal spread in properties for the 3 rock types. Both BSE and EDS image of thin section were obtained. Then finally, we extract grain from all the data we collect. So here are the results. The first one is the thin sections. In figure 4, that is a coarse sand, and the figure 5, that is a fine grain sand. Fine sand, sorry. So from this 2 data, we observe that this sample have clearly different grain size. We can see that in coarse sand, the grain is more big than in the fine sand. But however, when we investigating the enlarged section, that picture in the right, the grain size distribution and the pore structure has similarities. We can see. So with this data, we can conclude that porosity for the 2 samples are similar. After that, we have grain size distribution for samples, the satellite and the main field. The colors correspond to associate rock type determined during the core view. So we can see in coarse sand have more grain diameter than the fine sand. And the last one is data porosity versus permeability. For different sand component models to experiment data. So for digital rock models were created to represent these 3 different sand types. Each of these rock models were generated based on statistics from a single thin section. The digital rock model are also included. We observe that they are all aligned with the permeability trend for the core corresponding experimental values for associated rock types. So the conclusion or the summary of this research, the first one is, in contrast with both 3D imaging and traditional experiments, rock image technology gives the ability to do sensitivity studies by constructing 3D model where only one property is changed. This was exemplified by creating rock models with different grain size distribution, which revealed correspondence between grain size distribution and permeability. The second one is the direct relation between simulation and imaging offers a robust link between rock types and flow parameters. The imaging part of digital rock technology contributes to the rock typing. At the same time, simulation provides petrophysical and flow parameters directly related to the image and turbid rock types. This helps bridge the gap between geological interpretation, petrophysics, and reservoir simulation. And the last one, in the digital rock study described in this research, flow parameter from digital rock technology, flow parameter from digital rock technology was obtained in a time frame of 2 months, which was a fraction of the time used for traditional scale. This exemplifies how digital rock technology can be a tool for fast-track decision. Okay, so I think that's all for me. Sorry for any mistakes. Thank you for your attention. If any question, please ask me. Thank you.
Okay. Questions for Arfian? Okay, we have Bauya, and we have another one from the audience. Okay, Bauya.
Okay, thank you, sir. I think Arpian mentioned about rock typing, yes, in the summary slide. So can you explain more on rock typing?
Okay, thank you, Bauya, for the question. Okay, rock typing. Rock typing is, I think, is a process of classifying. Classifying what? Classifying reservoir rocks into distinct units, each of which was deposited under similar geological conditions and undergone through similar diagenetic alterations. I think that's the answer for me.
Okay. More question for Arfian from the audience? Okay, Arfian,
yes,
in the study that you have here, do you know what is the samples? What is the rock samples that you are measuring here? Is it all sandstone, or is it a loose sand, or any type of rock?
Oh, the focus on this research that I read, sir. So this is not my research, of course. I combined from another research. This use sandstone.
Sandstone.
Yes.
Do they have the location where the sandstone is located?
Yes, yes. I'm sorry, I'm not including in presentation, but there is a location in if I'm not mistaken, in India.
Oh, it is from an Indian sandstone.
Yes.
Okay. If I'm asking you about other type, because you're mentioning about any type of reservoir rocks in the summary or in the conclusion. So if you are going to extrapolate the chance of using digital rock physics for another type of reservoir, for example, for carbonates, and also for unconventional shale, for example, will we get the same result with this, or there will be different result?
Okay, so I think it will be different because this research is specifically for sandstone, sir.
Okay.
Yeah, specifically for this type of sand, as type of rock and type of sand, then type of condition. This type of condition.
Okay.
So maybe if they different places, maybe different method too.
Okay. 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 Thank you, Arfian. And due to the time period of our presentation today, praise to God, we able to deliver 6 presenters for today session, even though there are some kind of technical difficulties during the process. But we have 5 presenters because I think Fadila in the beginning of the session is unable to attend because due to her sickness. So in Thursday, we're going to present 6 more people, or 7 if Fadila is able to recover from her sickness. Thank you all for the presenters and audience who are participating in the discussion today. And so we're going to close our session today.